we're going to keep moving right along with our 15-minute segments. So next up is Keith Page from Selkirk Corp. So I'll ask Keith to come to the stage. Keith is the Applications Engineering Manager for Selkirk Corp's Commercial and Industrial Venting and Chimney Group. Keith is a committee member of NFPA 21137. He also sits on several UL venting and chimney technical committees. So ladies and gentlemen, please welcome Keith Page.
Thank you, Hal. Thank you for the opportunity here. Thankfully, my wife saw the picture ahead of the event and yelled at me for looking like an engineer, so here I am with a coat, and couldn't do much about the hair. I lost that in the Tough Mudder competition that Brian was talking about earlier. So, Selkirk got its roots back in the 70s. A gentleman named Don Panetta. Some of you may known him. Went on to have a good career with Selkirk, as well as EGSA, became a president in 94, I believe, and then retired from the industry in 99. So had a chance to talk with Don a little bit. He predates me and my time with Selkirk, but it was a pleasure doing that. So kicking into this, if you're not familiar with our product, we're at the tail end of the system. Here's my engineering humor again, but we're not depressed about it. So typically, exhaust systems, this is at the very end, the tail end, is a heavy Schedule 40 carbon steel pipe. Very common practice, been for years. But with that comes a lot of disadvantages. Field welding, for one, is a main concern. A lot of hazards can happen with that on job sites. And additionally, you've got field wrap, calcium silicate wrap. Does its purpose to some extent, but not overly protective of itself. Can also be an additional field, intense labor type of operation. So when you look at some of the perspectives of, you look at the advantages, really it's just a readily available system, carbon steel, Schedule 40 thick pipe, economical, readily available sizes, but there's a lot of disadvantages from as compared to a UL listed system. You've got, with UL listed systems, they're modular, so you don't have field welding issues. The supports in carbon steel systems are usually not well thought out, case in point with the image on the screen, on a stack that obviously started to collapse. Again, there's supplemental field applied insulation. You've got no corrosion resistance when you deal with carbon steel. And the oxidizing environment that exhaust gases do, especially if it's an outdoor system like that one, those sulfur infused fuels will eventually corrode that out, especially outside. So larger clearances to combustibles. Case in point, earlier this year there was a Boston fire that happened. They were on site, again, welding. Well, part of it was welding, part of it was just not clearances to a backup generator for a building. Thankfully, there was no injuries. It was not occupied yet, but it actually caused quite a bit of damage to this given building because the clearances were not taken into consideration on the single wall. No field-built thimbles, no factory support, and there's no warranty. So with UL-listed systems, we offer a full support program with that, design assistance, and then the overall life expectancy can be quite credible. So when you look at the hot strength characteristics of carbon steel versus a stainless steel, which is what you'll find out soon enough on what the factory-built systems are, there's quite almost double the tensile strength that you have with austenitic stainless steels versus low carbon steels at the higher temperatures, anywhere from 800 to 1,000 degrees Fahrenheit, or even up to 1,200 on some of the gen sets. A little quick ad. We did pros and cons, of course. Just going through some of the bullet points. Stainless steel, pre-insulated, durable, credible, clean look. Life goes on. So where this all came from, UL listed systems originally started out with boiler flue back in the early 70s, aka pressure stacks, and then eventually evolved into use on generator exhaust, turbines, eventually even into kitchen hood, grease duct world, pizza ovens, and the list goes on and on that we get uses for. We have a variety of options, starting with single wall to a handful of different double wall options. Again, all pre-insulated, stainless steel. The models are interchangeable, so you can start with one particular style in one area and maybe increase the insulation in another area in a building if you've got more concern with safety and clearances. So getting back to kind of the guts of these systems, they're 20 gauge stainless steel. We usually a 304 or 316 grade. Outer walls are usually anywhere from a 24 gauge aluminized steel, which is kind of like a galvanized look. It's paintable, and then 304, 316 option as well. And then the blanket options are anywhere from 1 inch blanket all the way out to 4 inch. Typical joint assembly, as I said earlier, is modular. These are a band and caulk type of system. So various lengths, various fittings, elbows, T's. Basically, you put the high temperature caulk in there, and then that holds a 60-inch water column pressure, suitable for suitable for the generator back pressures that we see in the industry today. And then you close the joint up with the trim pieces and insulation if necessary. The fittings we said earlier, T's, Y's, expansion joints. We use bellows joints for our thermal expansion components. Between fixed points, and then we get all the other components, starting bolted assemblies, bolted flanges, starter pieces, all the way to the termination, and then wall and roof thimbles. Some of the components, just kind of looking at some of the guts, these kind of all derive off of NFPA 37 as far as some of the requirements or suggested requirements. You've got one of the things we usually recommend on our systems, an ER revalve, unburned fuel potential especially in natural gas settings. So we usually highly recommend those systems on our product. And then we get on to some of the other starter components, a bolted flange connector starting piece, a bellows joint. Now the bellows, I said earlier, these are thermal compression device, thermal expansion component. These are not your vibration isolation components that usually start off with starting off from the generator. And then we get into thimbles, roof flashings as such, terminations, the old tractor flip top, miter cut wall termination, exit cones if you got to speed up velocity. We've got guy section requirements, or guy section ability if we need to go to a taller stack. All of our supports, we've got, again, UL listed components as such as saddles, wall supports, plate supports, anything to anchor it down to the building. But again, very modular, no welding on site. So some of the overview on what UL tests are. UL 103 is a chimney standard, goes up to 1,000 degrees, and then 2561 is a 1,400 degree chimney standard. And so every one of those UL standards looks at materials of construction, evaluates the safer clearances based on any given model that we have, mechanical strength and support test, so up to 4 times the support load that we have to publish. We even do a 110 mile an hour wind test, which for the given environment that we've seen in the last few weeks is quite appropriate. And then other tests, positive pressure tests, corrosion tests, and such, and then our installation instructions and UL labels. So some of the support charts, these are obviously little eye charts, so it's hard to see, but we've got anywhere, we can handle up to a couple hundred feet of stack and one single base support with just guide rings up spaced the rest of the way up if you've got a very tall stack. And then you've got some freestanding heights that we have anywhere up to 15 feet of freestanding above a lower support, and then guides. We've even done seismic testing. This chart's a little bit dated. I need to refresh that with my colleague Robert at some point in the future. But we've actually probably goes back quite a bit, but we put this in a laboratory out in California and did 30 feet of pipe and put it to the 10.0 Richter scale, and had data as such to provide that it withstood those, didn't fall down, didn't collapse, kind of shake and bake, so to speak, and did well. So we've done data of that such. And then you get into clearances. We've got clearances on like our 2-inch blanket model as far down to as a 1/2-inch airspace clearance to the outer wall, so very tight clearances for a given building. And then depending upon whether or not what model you choose, the clearances go up, and of course what size. As you can see on the chart there, we start at 5-inch ID and go all the way up to even 48-inch ID, so big stuff. And then your skin temperature is reflective of that. Anywhere, on average, if you go with one of our more common diameters and models, you'll be probably about 100 degrees above ambient. We do have thicker insulated product that'll get your skin temperatures down even more so. But in usual case, we stick with about our 2-inch blanket model or the 4-inch. I always like these shots here. This is kind of testing lab environment. We get to fire this thing up 1,000 degrees, and then we go to 1,400 degrees, and we get up to 1,700 degrees. In some other applications that we do, we actually even have to go to 2,000 degrees for 30 minutes. Now, I don't have that picture here, but it's neat to see the stainless steel actually become a little translucent once it gets to those temperatures. You'll get, when you get to a 2,000 degree setting, you can actually see shadows behind the other side of that pipe because it's glowing white. So it's kind of a neat aspect of putting heat to something. So this is a fire rated model that we have. So anything that needs an hourly rating, you may not be overly familiar with that part of it, but when you get inside the building and have to deal with the architectural and the code officials and having to break through fire rated walls and floors, we have a model that's specific for that. This thing gets dropped into a big tiki torch oven, so to speak, and gets engulfed in flames for up to 2 hours. And then we've got to have, we've got to meet criteria on the outside of that. So again, another fun test to watch. We do modeling, 3D modeling CAD, kind of put the components in a system. This happens to be a twin outlet generator. And then the silencer intermediate there in the horizontal, and then up the stack we go. This happened to be a 70-foot tall stack there. So up the side of or inside of a building, because we have a roof thimble on that one. So we do models for that, and then we even tag them with parts. We can do BIM modeling for anybody that's a little more progressive in the building architectural world for interference fit. And then we get into sizing. We have a sizing program. We do our whole backflow calculations. As long as we have the generator data, usually flue temperature and CFM allowance, and then all of our routing of pipe and length and height and fittings and all that, we plug that and then plug and chug, and this happens to have a 9-inch back pressure for this particular system that we did here. So, last but not least is the aesthetics, the clean look that you get with a double wall metal system. Again, stainless inside and then stainless options out, or galvanized out that's paintable. One of my favorite pictures is the one on the lower there where it's kind of the skyline at the night. It happens to be the top of Willis Tower, Sears Tower, overlooking Chicago West. I did not take that picture, thankfully, but somebody else did and gave that to me that I knew. So, other than that, thank you, and visit us at our booth there in the off time, and I'll pass the torch back to Mr. Hal. So.